Hello students, in the previous video we have learned Newton's first law of motion. The first law of motion indicates that when an unbalanced external force acts on an object, its velocity changes. That means when an external unbalanced force acts on an object, the velocity of the object changes. That means the object gets an acceleration. We would now like to study how the acceleration of an object, it depends on the force. We have seen when an external unbalanced force acts on an object, it gets an acceleration. And now we are going to see how the acceleration of an object, it depends on the force. Let us see some observations from our everyday life. You know that while playing table tennis, if the balls hit the player, it does not hurt him. But when a fast moving cricket ball hits a spectator, it may hurt him. And another example, a bullet. You know that bullet is having very small mass. But when a bullet which is fired from a gun, it may kill a person. This observation suggests that the impact produced by the objects, it depends on the mass of the object and also the velocity of the object. So, there appears to exist an important quantity that combines the object's mass and velocity. And that quantity was introduced by Newton and it is named as momentum. Now we can see what is momentum. Momentum is defined as the product of mass and velocity of an object. So what is momentum? Momentum is defined as the product of mass and velocity of an object. If an object of mass m moves with a velocity v, then its momentum is given as p is equal to m into v, where p denotes the momentum. And momentum has both magnitude and direction. And you know such quantities are called vector quantity. So momentum is a vector quantity and it is the direction of momentum is the same direction as that of velocity. And unit of momentum, kilogram meter per second. That's the SI unit of momentum. Kilogram meter per second. You know that m into v, mass into velocity. Unit of mass, it is kilogram. Unit of velocity, meter per second. So the product, that is unit of momentum, kilogram meter per second, or we can write kilogram meter second raised to minus 1. We know that an unbalanced force can change the velocity of an object. We have seen that when you exert an unbalanced force on an object, the velocity of the object will be changed. So from this formula we know that when the velocity of the object is changed, there will be a change in the momentum. So we can say that an unbalanced force can make a change in momentum of that object. The change of momentum of an object, it is not only determined by the magnitude of the force, but also by the time during which the force is exerted. So the change in momentum depends not only on the force which is exerted, but it depends on how much time the force is exerted on an object. So the momentum depends on the force acting on the object and also the time duration in which the force is exerted on that object. So that is the force necessary to change the momentum of an object. It depends on the time rate at which the momentum is changed. So from this we can state Newton's second law of motion. Newton's second law of motion can be stated in this way. the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. That is, the rate of change of momentum of an object, it is proportional to the force which is exerted on the object, and also the direction is in the direction of the force. This is Newton's second law of motion. Next we can see how to get an expression for force from Newton's second law of motion. That is the mathematical formulation of Newton's second law of motion. It's a derivation. Mathematical formulation of second law of motion. I told you it's a derivation. So first you have to give the introduction. I'll give you the introduction. In exam when it is asked, first you have to write the introduction, then the derivation. Consider an object of mass m moving along a straight line with an initial velocity u. So what is it? An object of mass m moving along a straight line with an initial velocity u. M is the mass, initial velocity it is u. It is uniformly accelerated to velocity v in time t. That is, after a time t, the velocity of the object, it changes to v. By the application of a force, that means when a force F acts on the object for a time t, the velocity changes to v. Is a clear introduction? Consider an object of mass m moving along a straight line with an initial velocity u. It is uniformly accelerated to velocity v in time t by the application of a constant force F throughout the time t. I hope the introduction is clear to you. Let P1 and P2 be the initial and final momentum of the object. That is, let P1 be the momentum when the object moves with the velocity u, and P2 be the momentum when the object moves with the velocity v. So first statement we can write initial momentum. So you have to write initial momentum P1 is equal to mass into initial velocity m into u. Isn't it? So initial momentum P1 is equal to mass into initial velocity u. And final momentum, that is P2. So if you want, I can write detail only. So initial momentum, final momentum P2, mass into final velocity. We know the initial momentum and final momentum, so we can find out change in momentum. Change in momentum that is P2 minus P1. We can write mv minus mu. It is given that the force is exerted for a time of t. So change in momentum we already calculated. Next, rate of change in momentum. Rate of change in momentum. That's equal to change in momentum upon time. Change in momentum mv minus mu upon t. That's equal to m is common, v minus u upon t. That is rate of change in momentum. According to Newton's second law of motion, we know that the rate of change in momentum is directly proportional to the external unbalanced force or the applied unbalanced force. So according to Newton's second law, rate of change of momentum proportional to the applied force. Otherwise we can write that the applied force is proportional to rate of change in momentum. So according to Newton's second law, of motion, what is it? Applied force is proportional to rate of change in momentum. What is applied force? F. F is proportional to, what is rate of change in momentum? M into V minus U upon T. M into V minus U upon T. But you know that what is V minus U upon T? Change in velocity upon time, that is the acceleration. So we can write M proportional to M into A as V minus U upon T is equal to A, that is acceleration. Now the proportionality can be changed by multiplying with a constant. Which is the constant? We can use the constant as K. So F is equal to K into M into A. Then what is K here? Bracket you can write, where K is the constant of proportionality. Is that clear? Here if you are doubt you can write bracket. Since V minus U upon T is equal to A. That's why we are substituting A. Now, the unit of mass and acceleration. We know that it is kilogram and meter per second square respectively. So the unit of mass it is kilogram, unit of acceleration meter per second square. The unit of force is so chosen in such a way that the value of the constant K it becomes 1. So you have to choose the unit of force in that way so that we should get the value of K as 1. So for this what you have to do? One unit of force is defined as the amount that produces an acceleration of 1 meter per second square in an object of 1 kilogram mass. So we can define force, one unit force. It is the force that required to produce an acceleration of 1 meter per second square on an object of 1 kilogram mass. So we can write it one unit force. What is it? That is K into 1 kilogram multiplied by 1 meter per second square. That is one unit force. Then what value you will get for K? That is 1 is equal to K into 1. Therefore K we will get it as 1. The value of K we got 1. Then substitute that value of K in this equation. This K, the value of K we are going to substitute in this equation. Yes, there only. The equation is there, sorry. The value of K we are going to substitute where? In the equation F is equal to K into MA. So when you substitute K is equal to 1, we get F is equal to M into A. Substituting the value of K in equation F is equal to K MA. We get F is equal to M into A. Understood? That means how much the magnitude of force is equal to mass into acceleration. F is equal to M into A. So force is the product of mass and acceleration of the body. The unit of force, from this find out the unit of force. What is the unit of mass? Mass it is kilogram. Unit of acceleration meter per second square. So the unit of force kilogram meter per second square or kilogram meter second raised to minus 2 or it is Newton. The symbol of Newton capital N. Okay. When you write the symbol it is capital letter N. When you write it in full you have to write it in small letters. So Newton is the unit of force. So the second law of motion gives us the measure of force as the product of mass and acceleration. Is that clear? And the second law of motion is often seen in action in our everyday life. We can see in which places we are making use of this Newton's second law of motion or in which places it is applicable. Have you ever noticed that while catching a fast moving cricket ball, a fielder in the ground, he gradually pulls his hand backwards with the moving ball. In doing so, the fielder increases the time during which the high velocity of the moving ball decreases to zero. Thus, the acceleration of the ball is decreased, and therefore the impact of catching the fast moving ball, it is reduced. And you know, if the ball is suddenly stopped, its high velocity decreases to zero in a very short interval of time. As a result, the rate of change of momentum of the ball may increase. It will be large, it will be high. Therefore, a large force, it would have to be exerted for holding the catch that may hurt the palm of the holder. That means if the ball suddenly falls in his hands or in his palms, it may cause an injury or it may hurt him. That's why the fielder, if he increases the time duration, the effect will be less. And another example, in high jump, the athletes are made to fall either on a cushion bed or on a sand bed. What's the reason? That also to increase the time of the athlete's fall to stop after making the jump. And as a result, the rate of change of momentum and hence the force will be decreased. Now tell me, a karate player, while breaking a slab of ice with a single blow, how he moves? A fast movement or a slow movement? You know that definitely it's a fast movement. That means there he is reducing the time. The time interval is reduced so that the impact is high or the impact is more. So these are certain applications of Newton's second law of motion. Now we are going to see how Newton's first law of motion, it can be mathematically stated from the mathematical expression of Newton's second law of motion. From Newton's second law of motion, we got an expression to find out force. That is, force is the product of mass and acceleration. But we know that acceleration is equal to change in velocity upon time. So in place of A, we can write F is equal to m into b minus u upon t. F is equal to b minus u upon t, isn't it? Now, cross multiply this. F into t, we get m into expand, m into v minus m into u. Now see, when the force F is equal to 0, that means when there is no force exerted on an object, F is equal to 0, that is there is no force acting on an object. You know that the velocity of the object will not change. So V will be equal to U, isn't it? And if the object is at rest, then the object will remain at rest only, and the object is moving. The object will move with the same uniform velocity. That is, when F is equal to 0, V will be equal to U for whatever time t is taken. This means that the object will continue moving with uniform velocity u throughout the time t. And if u is 0, then v will also be 0. That is, the object will remain at rest. If u is equal to 0, v also will be 0. Whatever is the time, if there is no force exerting on the object, and if the object is at rest, it will remain at rest only. And if the object is moving with a velocity u, it will continue to move with the same uniform velocity. Now tell me, what is Newton's first law of motion? The object will remain in its state of rest or of uniform motion until it is acted upon by an external unbalanced force. We have proved it now, isn't it? Clear to you? That is what we are stated from Newton's second law of motion. We are stated first law of motion. Is that clear? I hope the topic is clear to you. In the next video, we will continue with Newton's third law of motion. Thank you.